Okay, let's jump right into this explainer. If you're a BTech CSC beginner tackling topic 1.17 of your computer network syllabus, data link layer, services, and responsibilities, well, you are exactly in the right place. Sometimes those textbook definitions can feel a little dry, right? Kind of abstract. But today, we're going to make these foundational concepts instantly click by using a real-world story that I promise you won't forget.
So picture this. Have you ever tried delivering mail in a town with literally no house numbers, no street signs, and absolutely zero traffic rules? Imagine trying to drop off a parcel in that kind of chaotic environment. It perfectly illustrates what happens at the raw, physical layer of a computer network when devices try to communicate all at once without any sort of governance.
It is just pure chaos. Without rules, you literally just have raw ones and zeros constantly crashing into each other. Without some sort of organization, those raw bits just collide, get completely mangled, and basically get lost in the local network. And what that means is, well, we desperately need a system to manage the madness before any meaningful communication can actually happen between our computers.
And that brings us to the hero of our story, the data link layer. That's layer 2 of the OSI model. I want you to think of this layer as the local network's highly efficient courier management system. It's the organizing force that takes a chaotic, lawless town and turns it into a perfectly organized, gated community. Its whole job, its sole responsibility, is to organize, error check, and securely deliver your data to the right local devices.
So let's look at the first crucial step, packaging the data, or what we call framing. Think about loose ones and zeros like a messy, jumbled pile of random items you want to ship. I mean, you wouldn't just toss a bunch of loose sweaters, pens, and coffee mugs onto the back of a delivery truck, right? That would be crazy. Instead, the data link layer neatly packages these bits into structured boxes called frames. It's exactly like a courier boxing up items, sealing them up tight, and slapping a label on before delivery. Framing techniques, like byte stuffing or bit stuffing, make sure the receiving computer knows exactly where a distinct message starts and ends.
All right, moving right along to the next set of services. Traffic rules, which covers flow and error control. So, to prevent a super fast sender from completely overwhelming a slower receiver with just way too many boxes at once, we use flow control protocols. A really foundational example of this is the stop and wait ARQ protocol, and it acts exactly like a delivery driver who hands over one box, physically requires you to sign a receipt, and only then walks back to the truck to grab the next one. It is a controlled, safe, and paced delivery.
But wait, how do we handle boxes that inevitably get crushed in transit? Well, that's where we rely on error control mechanisms, things like parity checks, checksums, and the cyclic redundancy check, or CRC. You can think of these as rigorous, strict quality control inspections happening right at your front door. If the mathematical CRC check fails upon arrival, the receiver knows for sure the data was corrupted during the trip, so it basically rejects the package and just asks the sender to retransmit a fresh, undamaged copy.
Okay, on to our third major concept, house numbers, also known as physical addressing.
Even with perfect boxes, our courier still needs to know exactly where to go. So Layer 2 relies on physical addressing, specifically the MAC address. A MAC address is a permanent, entirely unique physical house number that is burned directly into your device's network hardware by the manufacturer. Unlike IP addresses, which, can change depending on what network you connect to, your MAC address is completely unchangeable. It guarantees that local network switches know exactly which specific machine gets the frame. Now, to make all of this actually work without a hitch, we follow a golden rule for the medium access control sublayer. Wait your turn before speaking. To prevent data delivery trucks from just crashing into each other on a shared cable, we use protocols like CSMA/CD for wired Ethernet. CSMA/CD basically forces devices to act like polite speakers at a crowded party. They literally listen for silence on the wire before they start transmitting. And if two devices accidentally talk at the exact same time and their data collide, no big deal. They instantly detect it, back off for a random amount of time, and then politely try again.
Let's pull all of this together in Section 4, the big picture, our gated community recap.
When we bring all these textbook terms together, the data link layer perfectly mirrors a highly reliable neighborhood courier service inside a gated community. We use framing for boxing up the parcel. We use MAC addressing to double-check that permanent physical house number. We deploy flow and error control to guarantee safe, perfectly paced delivery with strict damage checks. And finally, we rely on CSMA/CD for polite traffic rules to avoid collisions on shared roads. Honestly, when you break it down like this, Layer 2 makes absolute sense.
So our local neighborhood network is perfectly organized and running without a hitch. But now that we've mastered local delivery, I want to leave you with a final thought to ponder. What happens when we need to send a parcel to a completely different city? Our local neighborhood courier can't handle that. What new layer steps in when our data needs to leave the local network and navigate the massive global internet? Well, we're going to need IP addresses and routers for that whole shebang, which means stepping up to the network layer. We'll tackle exactly how that works in our next explainer. Thanks so much for joining me on this one.